Okay, hello everyone. So today we are going to discuss about the Wheatstone bridge. So let me first of all tell you okay, what is Wheatstone bridge. So what is Wheatstone bridge? Wheatstone bridge is the instrument which helps you in finding the unknown resistance. Means कि you are having a conductor whose resistance is you don't know the resistance of that conductor. So with the help of this Wheatstone bridge, we can find out the value of that unknown resistance. So now how it's possible, how it makes this Wheatstone bridge make it possible. So in this instrument what we have done, we have taken 4 resistance, 3 are known and 1 is unknown. Means के एक 3 तो known resistance है और एक क्या है unknown resistance है, and we have arranged these unknown in these 4 resistance in such a way that they forms a parallelogram. Okay, we have arranged these resistance in such a way that they are forming a parallelogram. एक resistance P हो गया, second one is Q, third one is S, and fourth one is R. So we have arranged them in such a way that the parallelogram is formed, and on the one diagonal we have arranged the galvanometer. एक diagonal पे galvanometer को arrange कर दिया, and on the second diagonal we have arranged a battery. यहाँ पे क्या किया, we have arranged this battery. यहाँ पर मैंने बैटरी को arrange कर दिया. Now what happened कि when this galvanometer gives you zero deflection means कि that the current is not flowing in this arm. इस वाले diagonal में current flow नहीं कर रहा है. Why current क्यों नहीं flow कर रहा है? क्योंकि हम लोगों ने ये resistance बहुत tricky way में adjust कर दिए हैं कि that in this galvanometer no current is flowing. Current is not flowing in this galvanometer. Now under this condition what happened? The product of these two, okay, product of these opposite branches means कि PS equals to RQ. PS equals to RQ means कि we can say P upon Q equals to R upon S. So this is the principle of this Wheatstone bridge. ये principle है Wheatstone bridge का. इस principle के ऊपर based we are having two different instrument. The one is the Meterbridge and second is the post office box. In these instrument, actually we have, these are the practical part we have done in the lab also. But we have to discuss theoretically also. So this is the principle of this Wheatstone bridge. On this principle, two instrument we are having. एक तो post office box हो गया and second one is the Wheatstone bridge. So we have to discuss them one by one. But before that, let us prove this principle कि ये आ कैसे रहा है. Now taking just from the diagram once again. So if I apply Kirchhoff law in these two loops, then what I get is, suppose we are moving from D to B. D से B में move कर रहा हूँ. From here we are moving against the direction of current. So I am getting I to R. I am getting minus in the direction of current means minus P I1 equals to 0, or we can say R I2 equals to P I1. So say this is the first, and similarly if we are moving from here to here, यहाँ से move कर रहे हैं आप, so then we are getting Q I1 equals to, in the direction of current, that means minus आएगा, minus we have to write minus, and then we are moving against the direction, so that means S I2 equals to 0. Simplify किया, S I2 equals to Q I1. Suppose ये second हो गई है, first upon second कर देते हैं, तो first upon second, when we do first upon second, this I2 gets cancelled, this I1 get cancelled, and we are left with R upon S equals to P upon Q. So this is the principle of Wheatstone bridge. Now let us discuss the instrument which are based on this principle. So let us take the first instrument, that is your Meterbridge. So why we are calling a Meterbridge? Meterbridge हम लोग उसको क्यों बोल रहे हैं? We are calling it Meterbridge because the wire which we are taken is of 1 meter. So suppose we have taken a wire of length 1 meter. एक वायर ले लिया है मैंने जिसकी लेंथ कितनी है 1 meter से, its name is AC. Okay, then different for unknown resistance we have to connect. For resistance मुझे connect करने हैं. So what we are doing, we are connecting the four resistance. यहाँ पे L शेप की दो wires we are taking for the connections. यहाँ पर भी connections के लिए आपके पास terminals होंगे. And यहाँ पर एक मैंने resistance box, suppose we have arranged a resistance box here. And here suppose in between this we are having a point which is called point D. And say from here in this part what we have to do, we have to connect unknown resistance. यहाँ पे तुमने unknown resistance को connect करना है, unknown resistance, and then this is connected with this. And from here what we have to do, we have to arrange a battery here. एक battery लगा दो, and battery के साथ if you want to increase or decrease the value of current, तो एक यहाँ पे एक rheostat भी लगा सकते हो. You can use the rheostat and then it is connected with the terminal C. The length of the wire is how much? It is 100 centimeters. Say 0 and here it is 100. Okay, ये क्या है? आपका rheostat है. Okay, this is called the rheostat. This is called a rheostat, and this is the battery. And this is the resistance box, and this is the unknown resistance. Say this unknown resistance का भी कुछ इसका नाम रख देते हैं. Say it is P and it is Q. Now at this point D, what we have to do, we have to connect our galvanometer. एक galvanometer लगा दिया यहाँ पर. Okay, galvanometer लगा दिया, and then this galvanometer is connected with this wire at point B. Okay, so see the arrangement here. This AB, ये आपका AB हो गया. Then this part is BC, ये आपका BC part हो गया. Then we are having DC, this part is DC, and this part is AB. So and this is the diagonal, so this is your diagonal. So now what we have to do, we have to move this jockey on this wire in such a way that we get a point where this galvanometer gives you zero deflection. जहां पे galvanometer की zero deflection आएगी, we have to move in this galvanometer in such a way कि this reads you, this gives you zero deflection. That zero deflection point is called the null point. उसको क्या बोलोगे आप? Null point बोलोगे. Suppose यहां से मूव करना स्टार्ट कर रहे हैं हम लोग. यहां तक वी हैव कवर्ड अ लेंथ L लेंथ पे galvanometer is giving you zero deflection को वो शो कर रहा है. So that means this length will be how much? This length will be 100 minus L, because the total length is how much? The total length is 100. Total length कितनी है उसकी? 100 है. So मैंने माइनस किया उसको, और माइनस करने के बाद क्या किया? What we have done, we have founded the length of part BC वाले part की मैंने length find out कर ली. Now this is P and this is what? This is Q. अब P और Q को निकालते हैं, तो रेजिस्टेंस P की जो वैल्यू आएगी कितनी आएगी? इट विल बी रो L upon A. L upon, say capital A we are taking, rho L upon A. Why we are taking rho L upon A? Because rho is the resistivity of the wire and area is the area of cross section. This is the length. Similarly, we can find out the value of Q also. The value of Q will be how much? It is rho 100 minus L upon A. Okay, 100 L upon A. And from here, if we divide this P and Q, और P को डिवाइड कर दिया Q से, सो रो गेट कैंसिल हो जाएगा. दिस रो L अपॉन A एंड इंटू A, दिस रो 100 माइनस से L, ये रो गेट कैंसिल्ड, A गेट कैंसिल्ड. सो सिंपली वी आर लेफ्ट विद P अपॉन Q इक्वल्स टू L upon 100 minus L. Okay, P upon Q equals to 100 minus L. So this we are getting. So now from here we know the value of this L की value मुझे पता है. We know the value of this P की value resistance box से we can calculate the value from the resistance box. And problem क्या रह गई है? L आपका मीटर ब्रिज से आ जाएगा जो मीटर स्केल which we are using. We are getting L from there, put the value here. So if you want to, this is your unknown resistance. So from here unknown resistance will be equals to how much? Q equals to how much? It will be 100 minus L upon L into P. Okay, and P is what? P is the resistance which we have taken from the resistance box. To avoid, minimize the error, two or more than two readings can be taken from, that means two or more than two null points by changing the different values of resistance can be found out from, can be calculated. Okay, to minimize the error. So this is your meter bridge and Wheatstone bridge. So next we are having the post office box that we will discuss in the next video. For today, thank you very much.